Well, let's take a look at this example. I've given just three simple values, 1, 1.5, 4, and 15. And we can see here the rug marks out the 1, the 1.5, the 4, and the 15. And you'll notice that we don't get, the kernel density estimate doesn't extend beyond the most extreme values in the data set. So let's see what happens when we change this parameter. Right now I've got BW set to 1. And what we can do, we can make it more jagged, that is more clearly identify the points by cutting down the BW. Change this to 0.5 and run the chunk again. And you notice now you see that we've got more clearly defined these extra points. Let's change this back to, oh, let's go out to 2. Let's smooth it a lot. And here we go. You notice now that you can't see the influence of the other points that are kind of blurred out by smoothing. So the next thing we'll do, I'll put this to use with an actual data set. I'll use diamonds, and to make it relatively small, take a sample of 5,000 points and look at the distribution of prices. And I actually did this, did a facet wrap by cut. It's kind of more interesting to do that. So first we take the sample and the GG plot and identify only one thing in the AES, that the X and price. And then we do geom underscore density, and I didn't do anything with the BW parameter this time. And then I did geom underscore rug, and I made the color red, and I made the alpha equal 0.05. And then I did a facet wrap with cut. So you can see separate densities of price for each value of cut. And the most interesting thing I think that I see out of this is that we have this ideal cut diamonds have this very strong low peak. It turns out that they're very lightweight diamonds, so they're not very big, and that's what makes them such a low price. Although you can see that the fair diamonds have a peak price slightly to the right of that. Okay, so I hope that's enough to show you how to play around with geom underscore density. So that's about all there is to this.